All right, we are going to review Unit 5. So Unit 5 is all about linear functions, which is a huge topic in Algebra 1. Super, super important. Something that you are definitely going to be using for or throughout all of your high school math years. So first off, Unit 5, we talked about slope. And slope is talking about the steepness of a line. I don't know if you've ever been skiing, but if you have, you know that there are different types of slopes. So some ski slopes are easier than others, and then some are like crazy difficult. And that all depends on how steep the slope is. Well, there's a numerical number, there's a value that goes along with slope. We write it as a fraction, and the reason we do is because the slope is the measurement of how high it goes up as it moves across. So the steeper the slope, the larger, or the steeper the hill or mountain, the larger the slope number is. And slope always uses the variable m. Don't know who decided it. M was available, but that's pretty universal for that. All right, now we have 4 types of slope. And if you remember, we watched Slope Dude, among other videos, and he was the puff puff positive, and then it was nice negative, and then it was zero fun when he was trying to ski flat. And then I remember it was like the worst curse word ever in math was undefined or no slope. So just to make sure you remember what we're doing on all that stuff. So if our line goes up as we go to the right, that's a positive slope. If our line goes down as we go to the right, that's a negative slope. If we have a horizontal line, that's when our slope is 0. And then when we have a vertical line, that's when our slope is undefined, or you could say we have no slope. All right. Another thing that I showed you when we were learning this was Mr. Slope. That was a picture. So give me just a second. Here, I'm going to go over to the side here and try and draw him so then I can explain oops. I'm not doing a good job at all. All right, I don't think I did a very good job on him, but in fact, he looks incredibly mad, doesn't he? Let me see if I can try it again. All right, but the idea here is that Mr. Slope helps you remember which one is which. Oh, he still looks so angry, but okay, what's happening here is his mouth is slope of 0 because it's horizontal. His nose is undefined, so that's the U to remind you that that's an undefined slope. When his eye goes up to the right, it's positive, and when it goes down to the right, it's negative. So that's another way that might help you remember slope. One other thing that I mentioned to you guys is that if you think of the letter N has a negative slope in it. So that might be helpful also. All right, finding slope. So to find slope, what we're going to do is we're going to figure out how much the line is changing as it goes up and over. So if you basically think about a set of stairs, okay, it's really important when the builder or maybe even the architect designs a set of stairs that they keep in mind how much the stairs are going to go up as they go over, up and over. And if you've ever walked up a set of stairs that's uneven, you can easily lose your balance. So what we're doing is we're measuring how much it goes up as it goes over. And that we refer to as rise over run. Rise over run is a very common way of talking about slope, and it usually helps people because we're going to go up and over, rise over run. We could go down and over. We could go up and left, but we're always going to go rise over run. If you're looking for an equation, you could do y minus y over x minus x. And the reason is because the rise is the y-axis and the run is the x-axis. So this is the rise and that is the run. So that's why we do the y on top. Now, when we were in class, what I showed you that I like to do is to stack them and subtract them. So what I'm going to do is give you 2 points. So how about 3, 7, and 4, 9. All right, what I like to do is I like to stack the points and then subtract the points. So stack them and subtract them. So if I stack them, now I'm going to subtract them. So 7 minus 9 is -2. My first one goes on top. 3 minus 4 is -1. That one goes on bottom. These two negatives cancel each other out, and I can just say that the slope between those 2 points is 2. All right, to give you another example, let's say that we have, how about 2, 5, and, I don't know, 3, 12. Okay? So stack them and subtract them. So 5 minus 12 would give me -7. All right? The first one goes on top. The second one goes on the bottom. So 2 minus 3 is -1. Those cancel. We can just write that as 7. All right. Let's say we had 9, 3, and 9. Let's do a -1. All right. So stack them, and then we're going to subtract them. So 3 minus -1 is 4. 3 minus negative means plus. 9 minus 9 is 0. And what I know about this is I can't divide by 0. 0 is not okay in the denominator, so this one is undefined. All right, so if you remember, I have a poster in my room that it's okay if 0's on top, but that is a no. 0 cannot be in the denominator of a fraction. All right, next up, let's talk about slope-intercept form. So slope-intercept form is known as y equals mx plus b. The reason why it's called slope-intercept form is because the slope is right there and the intercept is right there. So this is slope-intercept form. It's a standard form of the equation of a line, and not meaning standard form as in a name, but it's the most common form of a line. So what happens is if we look at y equals 5x plus 2, I can tell by looking at this that the slope of this line is 5 and the y-intercept is 2. Okay? If I had y equals -1/2 x, I can look at this and tell that the slope is -1/2 and the y-intercept is 0 because there's nothing there. So that's like a plus 0, oops, in disguise. All right. if I had y equals 7, I know that for this line, the slope is 0 and the y-intercept is 7. And the reason why I know that is because there's 0x. There's no x in here. So if I have 0x, it's not going to show up, which means that the slope must be 0. And then one last one. Let's say we had y equals x minus 3. So looking at this, I know that the slope is 1 because we know that there's always a 1, and the y-intercept is negative 3. All right, so that's slope-intercept form. So now let's start working on graphing. So we watched another video on this, actually a couple of them, with some, kind of catchy, trendy songs. I enjoyed them anyways. I thought they were pretty good. But what we always do is start with a B, and then we make steps to find where our line is going to be located. So on this one, let's do y equals 2x minus 3. All right, so first thing I'm going to do is graph negative 3. Well, that's my y-intercept, and that's because that's where it hits the y-axis. Now what I need to do is make a set of stairs. So if the slope is 2, that's because it's 2 over 1, which means I need to go up 2 over 1 and put a point. Up 2 over 1 and put a point. Up 2 over 1 and put a point. And once I do that, I have a pattern of points that will make a line. Okay? All right, another one. Let's try y equals, how about negative 2/3 x plus 1. All right, so I'm going to start with the y-intercept. So I'm putting a nail right here. And now, if you think about it, I have this nail and I have a piece of string, and I'm trying to figure out where the string should go. So what I'm going to do is I'm going to make a step. All right, now, this is negative. So what that means to me is that my line needs to go this direction. So I can rise 2, but I have to go left 3. Or I could go down 2, but I have to go right 3. Down 2, right 3. Up 2, left 3. And now I have a pattern of points that I can connect to make my line. All right, let's say that we have y equals 3. All right, well, if y equals 3, this tells me that the slope is 0. And if I remember, this is 0 fun because it's not easy to ski when it's flat. And if I also remember my Mr. Slope, I know that his mouth was made up of 0 because it was a horizontal line. So this is my y-intercept, which is still at 3. My y is on 3, so I go and I put a 3 on a y. I can put another 3. Here's another y. Here's another y. Here's another y. And now I have a horizontal line that is 0 fun to ski on. All right, last one for here. Let's do x equals 2. All right, now, when I think about this, I think of the form y equals mx plus b. And I can't do this as y equals mx plus b. So what this tells me is that there's a problem with this line. And the problem with this line is because it's vertical. So it only hits x at 2. So here, all of these are points where x is 2. So this has an undefined slope, and so it's a vertical line. All right, looking at this, can you write the equation looking at a graph? Well, sure, absolutely. in order to write the equation, I need to do y equals mx plus b. Well, that means I need to know the m and the b. So I can see right here that the b is 2. So I can look there and see that the b is 2. And if I try to make steps, let's see, it looks like I can go up 1 and over 2, up 1 and over 2, or I could go down 1 and over 2, down 1 and over 2, down 1 and over 2. So it looks like the value of the m was rise over run, but it's going in the negative direction. So now I can put this together, and y is negative 1/2 x plus 2. All right, next one is, again, let's try starting with the b. So that crosses right there at the origin. So I know that my b is 0. And then let's say that this one's pretty steep here. Let's see, if we go up and over there, so that's going up 4 and over 1. So up 4 and over 1, it's going in the positive direction. So that's a rise of 4 and a run of 1. So now we can say y equals 4x plus 0, which I don't really need to write. All right. Next up, let's write the equation if we just know 2 points. So I'm going to tell you that let's use, how about, oh gosh, I don't know, how about 3, 7, and 4, 9. Why not? Let's just do those two. All right. So I need to write the equation. So what that means is that I need to end up with y equals mx plus b. So keep in mind that in order to write the equation, I need to know the m and I need to know the b. Well, I have x and y's, but I don't have the m and the b. So first thing I need to do is figure out the m. Well, that's what we did earlier over here on our first page when we were finding the slope. So I'm going to start by just stacking and subtracting. So if I already have them stacked, so if I subtract 7 minus 9 is negative 2. 3 minus 4 is negative 1. The negatives cancel, and that equals 2. So now I know that the m is 2. So I need to hold that information right there. All right? So now we need to figure out the b. Well, without a graph, the only other option I have is to fill in everything else except the b. And I have 2 options because I have that as an x and a y, or I have that as an x and a y, and it doesn't matter which one. I'm going to use this one just because they're smaller. So what I'm going to do is I'm going to fill in the m, the x, and the y into this equation. So I'm going to do y equals mx plus b. The y is 7. The m is 2. The x is 3. And I need to figure out the b. All right, so let's see. So this would be 6 plus b. Well, if I subtract 6 from both sides, I can tell that b is 1. So now I know the b. So the answer for this equation should be y equals mx plus b. And when we write our final answer, we don't fill in the points for x and y. All right, very good. All right, last thing. We talked about similar triangles, and similar triangles are always going to have the same slope. So if we look at these three triangles, we might be wondering, gosh, are they similar or are they not? Well, what I'm going to do is I'm going to find the rise and the run of each triangle. So I'm going to go from this point to this point. So if I do that, I'm going to go 1, 2, 3, up 4. So I'm going to do up 4, and then 1, 2, 3, 4, 5, 6 over, but this is going in the negative direction. And I can reduce both of those by 2. So I got negative 2/3 for this red triangle. All right, so now let's try this one. I'm going to do this one in green. So I'm going to start here, and I'm going to go to here. So I'm going to count up is 1, 2, 3, 4. So I went up 4. 1, 2, 3, 4, 5, over 5, and it's in the negative direction. Well, I can't reduce anything there, so I got negative 4/5. But those are not the same. So I know that the red and the green are not similar. All right, so now I'm going to try this little one down here. So I'm going to do this in blue. Okay, so for this one, I'm going to start here and get to there. So I'm going up 2, so that was a rise of 2. And then 1, 2, 3, but again, this is going in the negative direction. So this one, I got that the slope is negative 2/3. So when I look at the three triangles that I have, I know that the red one and the blue one are similar. So red and blue are similar, but the green is not. And the reason why the green is not similar is because when I got their slopes, they were not the same. All right, that covers Unit 5. So on to the next one.